Okay, so this is the part number 5 and the last part of the series of video lectures in chapter number 8, term structure and volatility of interest rates. We will talk about yield volatility and its measurement. In assessing interest rate exposure of a security or a portfolio, we should combine effective duration, measure of effective duration with the yield volatility, because the effective duration alone is not sufficient to measure interest rate risk. Why we say that effective duration alone is not sufficient measure? The reason is that effective duration says that if interest rates change, a securities portfolios market value will change by approximate percentage change. However, the risk exposure of a portfolio to rate change depends on how likely and how much interest rate may change, a parameter measured by yield volatility. For example, consider a US Treasury security with a duration of 6% and a Pakistani government Treasury security with a duration 4. With a duration alone, we will assume that the US Treasury security is more risky, but are more volatile. But what if there is a more chance of fluctuations in the interest rate in Pakistan as compared to the US, right? So there, the other reason why it is important is that able to measure yield and interest rate why is that it's a critical input in various different valuation models. So in assumption of yield volatility is needed to value bonds with embedded options and structured products. The same measure is also needed to value some interest rate derivatives, right? So yield volatility is important. How to measure yield volatility? Basically, volatility of any observation is measured through standard deviation or variance, and the variation of any variance of any value or any variable can be measured using this formula, which we have studied in our introductory statistics course, right? In every introductory statistics course, which says this the standard deviation is the square of the difference between the each observation and value, and then we sum it and then divide by t minus 1. The percentage change in the yield assuming continuous compounding. So this is the variance, and the standard deviation is simply the square root of this variance. And then the percentage change in the yield, we are the thing we are talking about is basically the change in the yield curve. So the percentage change in the yield for the continuous compounding can be calculated using this formula: log of YT, yield today divided by yield yesterday, log of that, and multiply by 100. So for example, if today's yield is 6.593, yesterday was 6.555, and our answer will be 0.57804%. Right? Okay. Let's talk about calculating this variation using the historical data, right? Okay, I will again shift to this Excel embedded Excel file, which I have already created for this purpose. Okay, so here you can see time period from 0 until 25. So basically 26 daily observations, and YT, which is the yield from 6 from time 0 to time 25. The first thing to calculate is the XT, right? The XT, and the formula we use for XT is one I have just mentioned, right? So what we do is basically log, which is the natural log of, so we cannot calculate this for time 0, it will be started from time 1. So it is ln log price today divided by price yesterday, and we multiply it with 100, right? Okay, so it is 0.06720. Okay, and if I drag this down, I will gain all of these durations, right? So what I did is I just dragged this, and these are the different xt's, right? So next we have to measure xt minus mean. For that we have to calculate the average of this xt. The average of this xt is minus 0.9401%, right? So all of these are in terms of percentages. Then what we have to do is calculate xt minus x mean square. This one minus, here is our mean, and we have to square it, right? We have to square it. Okay, so whole power 2, and I have to fix this value so that I can drag this again, right? Okay, so once again I am dragging this, right? Okay, so now I will sum these. So the formula for the variance is sum of these squared values divided by n minus 1, 25 minus 1, right? 25 minus 1. So our variance here is in terms of percentage, 0.404559, right? And if I want to calculate standard deviation, it will be square root of this value, which is 0.6364, and so on, right? So this is how to calculate the variance and standard deviation. Okay, so what were the key points in this calculation of standard deviation? The key points here were: first, determining the number of observations. The selection of number of observations can have a significant effect on the calculation of the daily standard deviation, and this selection of the observation depends actually on the purpose. For some traders 10 days, for others 25 days, right? The second days thing is annualizing the yield, annualizing the standard deviation, which is basically simply the standard deviation multiplied by square root of days in a year, right? Okay. Third point, important point to understand here is using standard deviation with yield estimation, right? So what does it mean if the annual standard deviation for the change in treasury zero yield is 12%, right? So if it means that if the prevailing yield is 8%, then the annual standard deviation of the yield change is 96 basis points, 12% of 8%. And we can also calculate the confidence interval for the future yield, right? So what are the confidence intervals? So for example, is we have studied in our statistics that for the we know that there is a 68.3% probability that an interval between one standard deviation below and above the sample expected value will be bracket the future yield, right? So for the 3 standard deviation below and above the prevailing yield, there is 99.7% probability that the value will fall within these, right? So we can also calculate the confidence interval. Then we have historic versus implied volatility. Uh, we just discussed the historic volatility or variance and standard deviation. Implied will be market participants estimate yield volatility in using the interest rate prices of the interest options and caps. Problems with using this is that its estimation assume, so what they do is that they assume option pricing model and input the observed prices and all other values to do it option pricing model, and then try to estimate a volatility out of it, which is also one of the inputs. But the problem with this is that it is assumed that the pricing model is correct, and that the option pricing model typically assumes that volatility is constant over life, which actually is not. Then we have forecasting yield volatility. Suppose at the end of day 12, a trader was entered in a forecast for volatility using the 10 most recent days of trading and updating the forecast at the end of each trading day. What mean value should be used? Here, basically, simply, we use the concept of moving average. So the moving average daily values will be used, and all of you are familiar with how to calculate moving average, or you can refer to the exhibit 10 on page number 214 in the book, right? In other, there are, when you use moving average, there are theoretical arguments that suggest that it is more appropriate to assume that the expected value of the change in the yield will be 0 as compared to using the actual value. So you can use, you can drive a formula for that -0, this will become xt square and divided by t minus. So this is the simplified formula. In this simplified formula, we basically weight each observation equally, right? So in some cases, this weighted formula is also used. So this is the weighted formula in which some market participants gave greater weight to recent movements as compared to the later movements. So I think this is pretty obvious that how to calculate the volatility of the interest rates, or how to calculate the standard deviation of the interest rates, and then how to use this interest rate volatility along with the yield estimation. So this is all about this chapter. See you next week in our next series of lectures for chapter number 9, which is valuing bonds with embedded options. Thank you.